everyone, I'm Pranshi Verma from ABES Engineering College, Ghaziabad. In this lecture, we will explore Java Stack class and queue interface in detail. These data structures are widely used in various programming scenarios and are very crucial for efficient data management. Let's get started. First, let's talk about the stack. A stack is last in first out data structure. It's based on LIFO terminology. This means that the last element to the stack will be the first one to be removed. Imagine a stack of plates, and here you add plates on top and you also remove them from the top. In Java, the stack class is a part of java.util package, and here is the diagram shows the hierarchy of a stack class from the Java collection framework diagram. And here, first we have iterable interface, then we have collection interface, and then we have list. List is extended by collection interface, and collection interface is extended by the iterable interface. This is the main interface of our collection framework hierarchy. And here we have vector class. This is implemented by the list. The stack class extends vector and provides additional functionality, especially for stack operations such as push, pop, peek, empty, and search. And they are the main operations of a stack class. And a stack class indeed be referred as a subclass of vector. It's inheriting its methods and properties, and we can say that a stack is a subclass of vector and is a legacy class in Java that extend vectors. It is a part of Java since version 1.0. This means it inherits all the methods of vector, which can be both unnecessary and confusing. The stack class is not as efficient as other implementation of the stack data structure like ArrayList, ArrayDQ for certain operations because it's based on an array via vector that need to be resized, which can be costly in terms of performance. Now let's move forward and discuss some main operations of a stack. As I already told you, the stack extends the vector class with 5 operations that allow a vector to be treated as a stack. And here we have first operation is push. Push, as the name suggests, this operation is used to push an item onto the top of the stack. Then we have pop operation. Pop operation performs the removes of the object at the top of the stack and returns that particular object also. Then we have peek operation. It looks at the object at the top of the stack, and here the functionality of peek operation is without removing it from the stack. So next we have empty operation. Empty operation will help you to test if the stack is empty or not. Next we have search operation, and it's very important operation in all the stack operations. Operation search for the specified object in the stack and it returns its position relatively to the top of the stack, means we can say that at one based index. So it's all about a stack introduction and a stack operations. Let's discuss a stack example code to implement all the main operations of the stack. Let's discuss the stack class code example in Java collection framework. And here, first we have, and in this code, first we have package name, that is unit4 underscore CATL. And inside the package, we have just import the library, that is java.util.stack, to perform stack operations in the Java collection framework. Then we have our public class name, that is a stack example. And in this class, we have our main method, that is public static void main string args. And in this, we just define our stack class with the help of a standard syntax, as I already discussed in the previous lecture. First, we have class name, that is stack, then class data type, that is a string, then again variable name of our stack class, that is a stack, and equal to then new keyword, and then data structure type followed by angular bracket and method signature. So with the help of the syntax, we just declare our stack class in the Java collection framework, and then we just try to push element onto the stack with the help of push operation. And here, uh, how to perform push operation in stack. So first we have variable name, that is a stack, then dot put, then push operation, and in the bracket item we have to just into the stack. And first we have Java, then we have Python, and then we have C++. And then we just try to print our initial stack with the help of system.out.println method. And if you want to pop any element from the stack, so we can use .pop method with the help of a variable name, that is popped element, with the type of string. And then in line 18, we just print our updated stack with the help of system.out.println method. Next operation we have peek operation. As I already discussed, peek operation, with the help of peek operation, we can access top element of the stack and without removing it. So here, if you want to access top element of the stack, so we can use dot peek method, same as pop method, and just print our updated stack with the help of system.out.println method. It's all right. Let's move forward. And here, if you want to check our stack is empty or not, so we can use the is empty method to perform this task. We just print our updated stack with the help of system.out.println method. So it's all about we can perform all the main operations of a stack class in the IDE, means via code. Now it's time to run the code with the help of run button. So here is the output of our code. First, we have initial stack with our three elements, that is Java, Python, and C++. Then our popped element is C++, that is last element of the stack. Then if you want to access top element of the stack, so with the help of peek method, our result is Python, because our updated stack here is Java and Python. So because our updated stack here contain only two elements, that is Java and Python. So our top element of the stack is Python. And we just check is stack empty or not. So it returns false in Boolean, as our stack contain as only one element, that is Java, and it's not empty. So it's all about the output of this code. You can use this code in your examination. Here, all the main operation of stacks are covered. Now, let's discuss our next interface in the Java collection framework, that is queue interface. Now, let's discuss queue interface in detail. Queue data structure is based on first in, first out terminology. And we can see that queue data structure is based on FIFO terminology. The queue interface in Java represents first in, first out structure. This means that the first element added to the queue will be the first one to be removed. Think of a line of people waiting. And here, the first person in line is the first to be served. Since the queue is an interface, we cannot provide the direct implementation of it. In order to use the functionalities of queue, we need to use classes that implement it. And we have three main classes to implement queue, and they are array queue, linked list, and priority queue. So with the help of these three classes, we can implement queue data structure, queue interface in Java collection framework. Let's move forward. and discuss working of queue data structure. And here this diagram shows the internal working of queue data structure. And in this we have two ends. First one is front end and the next one is rear end. Here this diagram shows the working of queue data structure. And in this elements are stored and accessed in a first in first out manner. That is, elements are added from the behind and removed from the front. And we can say that elements are removed or dequeued from the front. And this is the end of the queue. And here, new elements are added or included at the rear part. Here, an arrow pointing to the front indicates that deletion, or we can say that dequeuing, occurs from this end. This follows the first out part of P4. Additionally, here an arrow pointing to the rear that shows that new elements are added, or we can say that queued from the queue at this particular end. And implement the first in part of P4. And here the direction flow of queue is from to left to right, with older elements on the left and newer elements on the right. So it's all about working of queue data structure. Data structure ensures that the first element added to the queue will be the first one to be removed. Much like a line of people waiting for a services, the person who arrived first gets served first. So it's all about working of queue data structure. Let's move forward and discuss some key methods of queue interface. It includes first we have add method. Add method is used to add the specified element to the queue, and it throws an exception if the queue is full, and it's not applicable for linked list. We have offer method. Offer method adds the specified elements to the queue and returns true if successful and false, maybe it's not successful. Then we have remove method. Remove method is used to retrieve and removes the head of the queue and throws an exception if the queue is empty. Next we have poll method. Poll method is used to retrieve and removes the head of the queue. It returns null if the queue is empty. Have element method. Method retrieves but doesn't remove the head of the queue. It throws an exception if the queue is empty. We have pink method. Method is used to retrieve but doesn't remove the head of the queue. It returns null if the queue is empty. So it's all about key methods of queue interface. Let's discuss a queue interface implementation with the help of Let's discuss queue implementation with the help of a code. Here is the code of queue interface implementation. And in this, first we have package name, that is unit4 underscore CATL. And then we just import all the required packages here. First one, we required java.util.linklist, and then we have java.util.queue. Within this code, we will implement queue interface with the help of linked list class. Then we have our public class name, that is queue example, and inside it, our main method, that is public static void main string args. And here, let's create our queue interface with the help of linked list class. And here standard syntax is followed, that is queue data structure data type, that is a string, then variable name equal to new keyword. And here we are creating queue interface with the help of linked list class, and so on. So now try to add some elements in the queue. Firstly, we just print in a statement, that is adding elements to the queue, and then some element in the queue with the help of dot add method. So firstly, we just add element1 named element in the queue, and as I already discussed with you, it throws initial state exception if the queue is full. Next we just add some element in the queue with the help of dot offer method, and here variable name that is q, then dot offer method, and variable is element2, and it returns false if the queue is full. We will see in the output part. Then we just add some another element here with the help of add method, and element name is element3, and then again we are using, and then again used dot offer method, and element name is element4, and then just try to print our initial queue elements with the help of system.out.println method. Now it's time to retrieve the elements in the queue. We can retrieve the elements of the queue with the help of dot element methods. And as I already discussed with you, it throws no such element exception if the queue is empty. Then we just print out this particular queue, and then we retrieve the element with the help of dot peek method. And what's the functionalities of peek method? It returns null if the queue is empty. And then just print our both the queue, that is head element using peek, and then queue after retrieving elements. And here we are using peek element and queue. Here we are using two variables to perform this task. First we have peek element and second one is queue. Now it's time to remove element from the queue with the help of remove method and poll method. Initially, we just print the statement that is removing elements from the queue with the help of system.out.println method. We just try to remove our element with the help of remove the element from the queue with the help of dot remove method. And as I already discussed with you, it throws no such element exception if the queue is empty. Then we just print out our queue elements after removing the first element of the queue, and then we are trying to remove element with the help of dot poll method. And what's the functionalities of poll method? Poll method returns null if the queue is empty, and then we just perform two tasks, and then we just print our both the queue with the help system.out.println method. And here we are using two variable name, that is polled element, and second one is queue. And now it's time to show remaining elements in the queue. So we can access all the elements of the queue with the help of just print them system.out.println method. And here we are using the queue variable name to perform this task. So now it's all about simple code example of queue data structure, simple queue implementation of queue data structure using the class linked list. Now it's time to run the code with the help of run button. Here is the output of our code. Initially, our queue contains the elements after adding elements, that is element 1, element 2, 3, and 4. Next, we are retrieving elements without removal. So first we have head element using element method, that is element 1, and then head element using peek method, it leads to be element 1 also. Now, queue after retrieving elements includes four elements in this, that is element 1, element 2, element 3, and element 4. Now, we are just removing elements from the queue. Firstly, we have remove method. So here, our output is element 1. Then we are just use poll method. So here, our output is element 2 because element 1 is already removed in the queue. Then queue after removing elements contain only two elements, that is element 3 and element 4. Next, we have remaining elements in the queue, and it contains only element 3 and element 4 because after this statement, that is queue after removing elements, and it includes element 3 and element 4, it doesn't perform any operations on the queue. So remaining elements are as it is present in the queue, that is element 3 and element 4. So it's all about simple program. So it's all about simple program of queue interface using linked list class. You can use this code in your examination. Please prepare well with code and their output. These are the references are used to design this lecture. In the next lecture, we will discuss set interface in detail in Java Collection Framework. Thank you so much for your patience listening.